Hey, what's up? I hope you have a wonderful day. You're watching Simple Coding. Starting this video, I'm going to publish weekly a series of videos that will show you how to build a microservice using Spring Boot. According to Stack Overflow Trends website, both Spring Boot and microservices have been getting tractions over the years since 2014. This video series is for two types of developers: those who have done some Java coding but has never done any web development, or those who have experience with Java-based web development but are not familiar with the Spring framework. Within this video, here's a list of things that I would like to introduce. First, what is Spring Boot? What is its relationship with Spring framework? Second, what is microservice? And what's RESTful API? What is the relationship between them? Third, how to start to build a Spring Boot based microservice through Spring Initializer. Last, how to build our first RESTful API for microservice using Eclipse. So let's get it started. First, what is a Spring Boot? Just as its name implies, Spring Boot essentially is a set of Java libraries that can be used to create a standalone, production-grade Spring-based application with minimum configuration. It has embedded web servers such as Tomcat and Jetty. It even has an embedded in-memory database called H2. The idea is that a developer can assemble the basic skeleton, say for a web application, using Spring Boot within a few minutes. The Spring framework is a group of Spring projects that are developed based on a set of common coding practices and styles. Each Spring project is a set of Spring-based Java libraries that can provide specific functionality. For example, Spring Security can be used to secure a Java application, not just the Spring application. And the Spring Data can provide a DAO layer to a database. Spring Boot itself is also a Spring project because Spring Boot works just like a ready-to-run Java application container. We can add more other Spring projects into it to provide more functionalities. Microservice is a concept. It refers to a conceptual technique that decomposes a large service into smaller subservices. For application development, a service is a discrete unit of functionality that can be accessed remotely and acted upon and updated independently. A service does not have to return a user interface such as HTML. It can take and return any predefined data structure such as XML, JSON, and HTML. So a microservice is a service itself, but only smaller, more lightweight, and access a smaller set of data stored in a single database. Nowadays, people often refer to microservices as a lightweight service that does not involve GUI, which make it more versatile to be consumed by different kind of clients, just like a traditional API. For more details, let's take a look at a service before it's broken down into microservices. Let's say this is a service of banking. It contains four modules: account to manage the accounts, payment to manage online payment and transactions, loan for home mortgage, and so on, report for monthly and annually statements and tax form. The service also communicates with four databases. And while a module can communicate with each other, like so, it might also directly communicate with a database that stores the data for another module, like so. Since this is a service that handles data without being tied up with a particular service client that displayed a specific user interface, it's quite flexible to serve multiple service clients, such as a cell phone or a web browser, and then each device or user interface will communicate with service directly, like so. Now let's take a look at how a service becomes a group of microservices. Now each module becomes a microservice, and each microservice will communicate its own database, like so. The communication between microservices will be strictly through microservices interface, like so. And one microservice cannot directly talk to a database of another microservice. Since each microservice is still a service, it's still quite flexible to serve multiple service clients at the same time, like a cell phone or a web browser. But now, each service client might have to talk to multiple microservices to render one user interface, like this. But usually, this is not a problem for each client. There are different ways to build a microservice. One popular implementation is web service using RESTful API. There are two important facts about RESTful API. One, it is a web application using HTTP protocol, much like a website, except that each API usually returns data in a data structure that is not HTML. The popular data structures are JSON and XML. Two, it's stateless, meaning that both the web service and the web service clients do not track subsequent communications between these two. So to summarize, a RESTful API is a common implementation of a microservice, and it is essentially a stateless web service based on HTTP protocol. Okay, let's build our first microservice using Spring Boot. To do that, there's two ways. You either create the Java project using Spring Boot if you know the structure by yourself, or you can use a tool called Spring Initializer. A Spring Initializer is a Spring website that allows you to specify the basic parameters for the project, and then the site will build the project basic structure for you and allow you to download it as a zip file into your hard drive. For this video, we are going to use this method. So this is a website for Spring Initializer. Let's provide the group ID. Let's call it org symbol coding dot Macroservice. We will leave the artifact ID as demo. Next, we need to select the dependency. We have to select the web because the default Spring Boot does not include the web dependency, which is required for us to build the microservice. So we will select the first one, then click Generate Project. Now you see that we have this zip file downloaded into our hard drive. Now we have a zip file. Let's unzip it. Now the zip file has been unzipped. Remember, we used the Maven as a build tool. So now you see the POM file, and also you have the source folder. Let's open up. Then you have a main and a test. These two folders are default for Maven projects. Next, let's import that project into Eclipse IDE. To do that, open the IDE, go to Import, select the existing Maven projects, click on Next. Let's select from our download folder, Data Project, select folder, Now the POM file is already selected. Click on Finish. Now we have a project within Eclipse. First, let's take a look at the Maven POM file. Notice in this POM file, there is a parent tag. Actually, this is a Maven dependency. There are two purposes of this special dependency. One, this start parent will pull down all the required Spring libraries and third-party libraries for the Spring Boot. Second, it will dictate the version of the Spring Boot, like so. Notice the two other related dependencies for this Spring Boot project do not have the version, because the version number has been determined by this parent. Also notice that we specified the web dependency. Now we have this Spring Boot starter web. Next, let's look at the only Java code that Spring Initializer created for this project. Notice by default, Spring Initializer named this class with Maven's artifact ID that we specified and the suffix application. It contains a Java main static function, which means this is a standalone Java code to start this Spring Boot application. Also notice that there is a Java annotation applied to this class called Spring Boot application. This is a Spring Boot annotation, and as its name implies, it indicates that when we execute this class, Spring Boot will perform several bootstrap steps. For this video, we are not going to go to the detail of these steps. We just need to remember that this annotation is required to enable a main Java class to start a Spring Boot application. Also, as you may already see, the main function only contains one line of code that invoke the Spring application, a Spring application bootstrap class to run our Spring Boot application by passing in this class. For our demonstration within this video, we do not need to add anything to this class. Now let's build our first RESTful API. To do that, we need to create a Java class and mark it with 3 Spring annotations. Normally, we have to create a separate Java package or multiple packages for better organizing the code. But for the simplicity of this video, let's just create the new class within the same package as the main class. This is a class to perform as a controller for a new API. A controller in Spring Boot is a Java class that handles API requests from an API client. Usually, it handles various APIs related to the same kind of a resource, such as a checking account in a banking system. As a good naming convention, let's call it checking account controller with a prefix checking account to indicate that this is a controller within Microservice that manages bank accounts, including checking accounts. And this controller specifically handles APIs for managing checking accounts. Now let's write a public method for this class called getAccounts. This method is going to be the code that handles a getAccount by account ID API. So this method will take one string parameter called account ID and return a string as well. Normally, such method should return a specific type of object called the response entity rather than a simple string. But for this video, let's just return a string to see what will happen. The string that will return is just the phrase account ID followed by the actual account ID from the method parameter. At this point, what we just created is just a simple Java class with a simple public method. To enable this class to become a Spring Boot controller, we have to add 3 Spring annotations. The first one is a REST controller annotation above the class declaration. This annotation indicates 2 things. One, this class is a web controller that will handle HTTP requests. And 2, its return value will from an API method within will be bound to HTTP response. In other words, the method return value will be wrapped into HTTP response object. The second one is a request mapping directly above the public method we just created. This annotation indicates this method will handle a specific API. This annotation also has to have 2 attributes. The first one is called method. This tells Spring Boot what HTTP request this method can handle. We will specify a get method like this. The next one is path. Let's give it as checking accounts. Which will be part of the web URL for this API. For those who are not familiar with the structure of typical web URL, let me explain it a little bit. A web URL contains these basic components: a protocol, domain, port number, context path, and a path. So for this API, the URL will be started with protocol http / and the local host is domain, followed with port number 8080, and then this URL does not have the context path. It only has path as we specified in the request mapping on the annotation. So it will be checking accounts. The third annotation is a request parameter that to be added before the method parameter account ID. This annotation indicates this parameter is also a query parameter for this request method get under this URL. So this is actually the parameter to our new API. So for testing purpose, if you need to specify this end parameter, all we need to do is add the question mark at the end of the URL that we just specified, followed with the parameter name, and then whatever the account number will be, like so. Let's save it. Now we should have this new RESTful API to be ready for testing. Before do that, let's put a breakpoint in the return line, and then let's start this application. To do that, just click on this one, and then right click, say debug as Java application. The application is start up. Notice that the port number is 8080. This is because the embedded Tomcat is used for this application execution, and its default port number is 8080. There are multiple ways to test a RESTful API, and some of them can be even automated so that the same task can be executed repetitively. But for this video, we will just use a simple browser. I do need to point out that a web browser is not an ideal tool for such testing because quite a few reasons. But just let's use it for our video. So let's specify the same URL that we just mentioned. Remember, we needed to specify the parameter. Now you see that this line is executed. Let's finish that. Come back. You see the result. So let's change it to something else. Enter. Come back. Now the account number has been changed. Okay, that's it, folks. This concludes this tutorial video. I will post the next tutorial quite soon. If you like this video, please give it a thumbs up. If you would like to provide feedback, please leave comments below. If you like this channel, please subscribe. Until next time, happy coding!